All right. So, um, in this section, 6.3, we're just going to multiply and divide rational expressions. So 6.3 is just how do you take two rational expressions and multiply them. And they actually wrote down a few things that we can do first. So before you go to multiply your rational expression, you guys want to simplify your rational expressions. And so here's an example of numbers, and here's an example of a rational expression. A rational expression is just when you have a polynomial equation up there and a polynomial equation down here. But the very first thing you guys need to do is make sure everything is factored, because you can't cross things out if they're not factored. If you're going to cross things off, you can't cross off individual pieces. So you can't say x minus this x. That will be incorrect. Whatever you see in parentheses must also have the exact same thing so you can cross it out, because ideally they're dividing. So before we even go to multiply or divide rational expression, we're going to see if it's all factor out. Can we simplify anything first? So not really too much to do on this page, but the next page walks you guys through, well, how are we going to multiply a rational expression? And it turns out, after we simplified, so first, we're going to factor everything. 2, we're going to simplify by crossing anything that's at the top and at the bottom. Now, they don't have to be right underneath. You don't have to write it out like this. You can start from here, and you can just cross off this x with that x. Only the top and bottom cancels out, because it's like x divided by x, which is 1. So after you factor, you're going to simplify. Once you simplified 3, you guys are just going to multiply across. And that's pretty much all you're doing when you're done. You're going to go in and multiply rational expression. One quick thing is right at, maybe I should have said step 2 here. Let's switch our steps here. I want you guys to identify your domain restrictions here. And so let's do the example so you guys know what I mean by identify the domain restriction right after you guys factor. And the next page, some multiplication ones, starting with one of the example of a multiplication problem like this one. Let's do 8 as our example here. Okay, so first thing is we got to factor everything. I would just do the factor work right at the top. So this is where you have to be really good at factoring. Okay, this is a quadratic, so I need two numbers that multiply to be -3 and add to be 2. -3 and 1, does that work? Multiply to be -3, add to be -2, good. Okay, you go to the next piece. This piece, I need to see two numbers that multiply to be 63 negative and add to be 2. 7 and 9, and 9 is the negative. Okay. Is this piece factor? Not yet. It's a difference of squares. And then this piece also needs to be factored. Two numbers that multiply to be -21 and add to be 4. 7 and 3, and the 7 is the positive. Okay, so this is where you have to be really good at factoring, because that's the first thing you guys have to do, factor everything. Yeah. Oh, it was -21, so that's a -3, right? Okay, so once we get to this, step 2, I want you guys to identify your restrictions, your domain restrictions. So the domain restrictions are down here. You can't have 0 in the denominator. So you look at each factor piece. Your domain is x cannot be a 1 because you're going to 0 the whole bottom piece out, and we can't have 0 in the denominator. X cannot be -1. X can't be -7. X can't be +3. So I like to list my domain restrictions because right when you're done factoring, you're able to identify them easily. They are the pieces that make your denominator 0. Yeah, but they're still going to be open dots, so you can't use those if they cancel out. So you want to state it right away. Okay, so now you're on to step 3. Let's simplify it. So you're going to take a look at this. What's at the top and bottom that are the same? I see that whole thing. I see this whole thing. I see this whole thing. Those all simplified out. These got divided out into 1. These got divided out into 1. These got divided out to 1. That's what's left, and then you're just going to multiply across. So you just have a x minus 9 at the top, and then you just have left an x minus 1. And that's what we mean by just multiplying across. There was nothing to multiply the x minus 9 anymore. That one. And that's and you're done. That is all you need to do. So let's do that again for another multiplication one. This number 9. Okay. First thing is factor everything. X, I can take out an x, and that's that one. This is a sum of cubes. You guys remember how to factor the sum of cubes? Okay, x plus 2, because that's 2 cubed. So then it is x squared. It is 2x, and then it is 4. But then it is the same, opposite, always positive. So that's this one. It actually factors out into both of those, but it's a difference of sum of cubes. Oh, this one's already factored, so we don't have to do anything. I would actually put a parenthesis on that, so I'm looking for that to cross off, and I won't mistake to just cross off the x's. This one, it looks like I could just take out an x, but when I take out an x, this one becomes a difference of squares. Okay, everything has been factored. Oh, whenever you do a sum or difference of cubes, this part can never be factored. It looks like it's a quadratic and it could be factored, but you won't be able to find a factor. So that part you're going to leave. Okay, once you get it all factored, go and identify the x's you can't use. Look at the denominator. This first one, you can say, oh, I can't use the -7. I can't use a 0 from this one. I can't use a +2. And I can't use a -2. These are the x's you cannot use in this equation because they make the denominator 0. Okay, step 3, let's just cross off things that are at the bottom and at the top. The x here, that x there, that x minus 2, the x minus 2, the x plus 2, the x plus 2. Then we're just going to multiply across, and across, it looks like we only have the x squared minus 2x that's left. And at the bottom, it looks like we just have a x plus 7 that's left. So that's it. That is my rational function multiplied together. Okay, let's try division. So when you do division, let's write some steps down for division. Go back to this page and go to the division part. When you guys do division, you still have to factor everything. 2, you guys have to identify your domain restrictions again. So steps are the same. What x's can you not use? You could tell easily after everything's been factored. And then 3, you guys are going to multiply by the reciprocal. After you flip your second piece, that's when you start to simplify and then multiply it across. So you guys remember when you were dealing with fractions and you have a over b divided by c over d, you just multiply by the reciprocal and then you multiply across. That's the same idea. So after you guys multiply across, I want you guys to go ahead and actually there's I keep on forgetting, but there's a second spot here. I want you guys to re-identify your domain restriction. Once you flip your inequality, re-identified your restriction because you put something in the denominator and you can't use those x's. So there's going to be 2 places you guys are identifying your domain restrictions. Okay, let's try example 7 for that piece. See if we can fit it all together. Oh, what's nice about example 7? Okay, it's already factored. So let's identify the restrictions. I cannot use a 2. Let's just put a parenthesis there so you guys don't cross that x with that, because that part has to be crossed off with an x minus 2. I can't use a positive 6, and I can't use a 9. It will make the bottoms 0. Yeah. If you put a 2 here, it's going to be 2 minus 2, and you will have a 0 in the denominator of your rational expression. And with rational expression, you just can't have zeros in the denominator. It's like 2 over 0. If you had 2 apples and you were supposed to give it to 0 people, how are you going to do it? You can't. So you can't have 0 down there. So you're looking at the bottom pieces. It's already factored. We identify restrictions. Let's just flip the second piece. So flip the second piece. The first piece does not need to be flipped, only the second, because you're multiplying, you're changing the division into multiplication, and then anything that comes right after it gets flipped. Okay, after you have flipped that, you need to check again, since you put different things in the denominator now. X cannot be -1, and we already identified a 6 from this one. So there's another restriction. You can't use -1. Yeah.
So what makes the restriction?
The restriction is just based on the definition of a rational expression. You cannot have 0. You can't have x's that make the bottom 0. When you put a -1 here, it will 0 this, and it will 0 everything. Anything that makes the denominator 0 cannot be used. Oh, well, the 9 is also a restriction because it was a restriction of this one individually. So when you identify the first restriction, you're identifying them individually. You're saying I can't use 9 when I have this rational expression. The second restriction is when you combine them as a multiplier and you flip that over, because that's going to land in the denominator now. So you can't use all of those x's. Because if you use the 9 from the beginning, this one will never work. So identify them after you factor, flip them, re-identify. There's more. There may be more that show up. And in this case, it showed up another time. We can't use -1 also. Then you're going to simplify next. So let's see. We can cross that one out. We can cross that one out. Okay, those are crossed out now, and we're just gonna multiply across. So when I say multiply across, we're just gonna write them together. We're not gonna actually distribute them. We're just gonna say x times x minus 9, x minus 2 times 1. So that is our simplified problem with these restrictions. Okay, let's try this again with the last division problem right here, number 10. Okay, this one's not factor, so we have to factor everything. Okay, the top two numbers that multiply to be negative 15 add to be 2, 5, and 3. And is the 3 negative? Okay, let's cross that off. Two numbers that multiply to be 40 and negative and add to be 3. I'm gonna get them to add to 3, but they have to become 40. Is it 8 and 5? Okay. Negative 8, positive 5. Okay, how about two numbers multiplied to be 9 negative and add to be 8? 9 and negative 1. And then two numbers that multiply to be 72, add to be 1. 9, 8. Okay, everything is factor. Once everything's factor, it's easy to identify your restrictions. So x cannot be at 8 here. X cannot be a negative 5 here. X cannot be a negative 9 and 8, but we already listed it, so we don't need to list it twice. Okay, since it's a division problem, this second part needs to be changed. How? Just flip it, make it a multiplication. Flip only the second part. Okay, once you flip this second part, there's other pieces in the denominator. So I already stated that x can't be negative 9, but I never stated that x can't be 1. So that's another restriction I can't use. So I got all my restrictions done. We're on to the steps of dividing. It has to be the whole quantity that gets crossed off. Multiplication is commutative, so since it's just all multiplication, not separated by any pluses, I could say that one and that one divides out. These divide out. These divide out. And that's all I have left. So an x minus 3 remains at the top, and across an x minus 1. And that's your division of two rational expressions. Yeah.
For example, it's like the on top, right, it's like the x plus is cancel out. You multiply the remainder.
Oh, so say they didn't cancel out and you still have like a that times that and or numerator or denominator. In some textbooks, yes, but our textbook just says leave it, so we're gonna leave it because some of them will say multiply all out, but we're gonna just leave it and we're gonna say that times that. So that we, I think that's how our textbook likes to answer. They rather just have you leave it all factor out, but you still put them together next to each other. Now, another thing I want to tell you guys what our textbook likes for the restrictions. So, this is actually what our textbook will do. They won't include this one as your restriction. So in your homework tonight, they won't include that because they're saying that because this piece never got crossed out, you would still know that x can't be -1, but it's still in your equation, so you don't have to state it. Does that make sense? In some textbook, they will just state everything and say you can't use all of these x's. But our textbook, for some reason, they said, oh, that's still left, so there's no reason to state it because someone who knows math will still be able to say x can't be 1. Does that make sense? That's just how our Big Ideas textbook would do these problems. Yeah.
So it won't include domain restrictions that don't cancel out?
Yeah. So our textbook won't include the domain restriction that don't cancel out because they're saying you should still, someone who looks at your last answer will still be able to identify them. But the ones that cancel out, you won't be able to tell, right? If you were just looking at that and you never list them, you would never know that you weren't supposed to use a -9, -5, or an 8. So since it got canceled out, you do have to list them. But if it didn't get canceled out, you don't have to list them. On the test, if this is a free response, you guys could list all of them, or you could just list the ones that don't cancel out. I'll still know that there's more, but we'll sort of follow our textbooks the way they like their answers to. I know different years when we use different textbooks, they list everything. They said even though it's there, you probably want to still identify it. But I know Big Ideas does that instead. They don't like to list the ones that don't cancel out. Okay, let's finish the rest up there. The other easy ones up here, and then this should be the end of our notes. Okay, so there's actually not much factoring that needs to be done. You're just gonna go to identifying your restriction. So right away, you're gonna say, oh, x can't be 0, y can't be 0. That's it. Then you're going to cross off anything that you see that's at the top and bottom. This y cancels out with one of those, but this y will cancel out with that y, so no more y's. And then it looks like one of these x's cancel. So now across, you guys have a 3 and just an x. So what will our textbook list as a restriction here? Our textbook will only list that y can't be equal to 0. They won't list the x can't be equal to 0 because it's still in our final answer. Does that make sense? Oh, the 2 is still there? It's right there. Okay, on to the next one. Now, these, I want you guys to put a big parenthesis here because that blocks you from canceling this y with that y. And you don't want to cancel just yet because it's a division problem. So you want to flip this second one. Oh, let's state restrictions. X can't be 0, y can't be 0. The variables and the denominator. Okay, we're going to flip, put the y up there, put the 4x down here. Okay, again, put parentheses right here to block you from canceling that y with one of those y's. That y is attached to the x, so you need to find another x plus y in the bottom to cancel. The ones that cancel is just that y, and that's all. At the top, you're going to have x plus y that remains, and at the bottom, you can say 7 times 4, and then x times x squared. Yeah.
So the x and the y, they're always going to be x equals to 0.
Well, it's because it's multiplying. There was nothing attached to it. Yes. So like if it was just an x, if you make it 0, is 0 is the bottom out. But if it was an x plus 2, then you need to put a 2 negative in. So this was just an x. If you make x 0, 0 is everything out. If you make y 0, 0 is everything out. So when it's just an x or y, it's just 0. But when it's x plus something, then you have to put the opposite to 0 it out. Okay, so this one, the tricky thing is right there. You can't cancel these x's with that x because it's not multiplication anymore. There's a plus there. So whenever there's a plus, you have to put it all together. And you're looking for another x plus y in the denominator, but there wasn't. So this is all we would have, and our textbook will probably just state this instead because the x is still there. So we know that x can't be 0, but the y happened to disappear out of the denominator. So we need to list that there so we know that y was never allowed to be 0 for this one. So sometimes it's a division problem, but the factoring part is all done, like number 7. Number 5 and 6, there was actually no factoring. So you didn't have to do any factoring before you start identifying and then simplifying over. Okay, comments about these?